Happy Halloween, students. Here we have the periodic table in the form of a chemistry amusement park. So your project due next week is to show your prototype, your three-dimensional model of your chemistry amusement park. And the chemistry park needs to include really all the different topics we studied in chemistry. Starting with the atomic structure, so the structure of the atom. So remember, protons and neutrons are in the nucleus of the atom, they're in the middle. The electrons are spinning around the outside. Protons, neutrons in the middle, electrons spinning around. Just spin like that. Spinning like that. Spin around, electrons. So, you already did the amusement park ride that represents an atom, so you just use that. In fact, you have the video of it, so just include that video of your ride into the entire video of your amusement park. Some other things you need to include, we talked about. Types of reactions, chemical versus physical reactions. And when we talk about physical reactions, remember, you're not actually changing the chemistry. So in a physical reaction, the before and after are chemically the same thing. So the reactants and the products are not chemically changed. They're the same. And in a chemical reaction, the before and after are different. They're chemically different. That's why it's called a chemical reaction. If we look at physical reactions, or physical changes, an example would be phase changes. So when phase change happens, for example, in dry ice, when you're going from solid carbon dioxide to gas carbon dioxide, that's a change of the phase of matter. It's going from a solid directly to a gas. But it's still carbon dioxide. But the before and after are still CO2. So if it's still carbon dioxide before and after, there's no chemical change. So it's a physical change. And that process is, that phase change is called sublimation. Sublimation. Sublimation means going from a solid directly to a gas. And dry ice is an example, because dry ice is frozen carbon dioxide. And it's called dry ice because when it melts, it doesn't become a liquid phase. It goes right to a gas. Whereas wet ice, or the ice cubes we have in our refrigerator or in our freezer, made from water, when that melts, it becomes a liquid. And then if you heat it up even more, it becomes a gas. But carbon dioxide doesn't go through the liquid phase. It goes right from a solid to a gas. And that process is called sublimation. And that happens when you're adding more thermal energy. So when you're adding more thermal energy, the atoms in the carbon dioxide molecules are going to start moving more. And when they move more, that really is measured in temperature. So when they're moving more, they have more kinetic energy, and that kinetic energy is measured in the temperature. So the temperature goes up. So movement, temperature is really just a measurement of the kinetic energy of the atoms or molecules. And in carbon dioxide, when it's frozen, like dry ice, the molecules are not just vibrating. They're not moving much. So here we have carbon dioxide. Here's carbon dioxide, and carbon dioxide, CO2. In a solid, when you're in dry ice, for example, the molecules of carbon dioxide are just vibrating like this. They are moving them, because remember the kinetic theory of matter indicates that all atoms are really moving, even if they don't seem like, even if they're in the solid state. As you add more thermal energy, so for example, with the dry ice, you take it out of the freezer, it starts to melt. It doesn't really melt. It's not called melting, but it's similar to melting. It's called sublimation. So it starts to sublimate. And when it does that, it goes into a gas form. So in a gas form, remember, the molecules, like carbon dioxide, are moving around more. Moving around. Gas. More kinetic energy. So the temperature's higher. Okay, so that, if you think about the phase changes, going through different phases of matter, going from a solid to a gas, for example, sublimation, we're adding more thermal energy or heat, which increases the temperature.